Problem statement. You roll a die. Let's define two events. A, that the number is even. You can have 2, 4, or 6. Event B, that the number is greater than 3. You can have 4, 5, or 6. Are these two events independent? In other words, are they related? These types of questions are answered by multiplication rule. This session is about multiplication rule. By the way, the answer for this is no, they are not independent. So let's review the definition of probability. Probability of an event E is defined as the number of favorable outcomes divided by the total number of possible outcomes. So another way of writing the same expression is probability of E is defined as the size of your E divided by the size of your sample space. So let's understand this through a simple example. In a two-coin toss, the question is, what is the probability of getting both heads? So here my sample space is I can get head head, I can get head tail head, and tail tail. So I just drew this sample space right here over here. So these are my four elements of my sample space omega, this one. Now in this case, my event E is both toss are heads. So my head head right here. So this is my event E, which is denoted using a Venn diagram like this. So in this case, the size of my sample space is 4 because I got 4 elements in my the whole thing, right? And the size of my event E in this case is 1 because there is only one element right here. So my probability of E is going to be 1 over 4. I'm just using this formula right here. Now, the multiplication rule, it is used to find the probability that two or more events they happen together. That is the intersection of two events. So mathematically, for two events A and B, you use this expression to define probability of A and B. In this case, P A intersection B, this right here, this is called probability that both A and B occur together. This one right here, PA, it means probability that event A occurs. This right here, it means probability that event B occurs given that A has already occurred. So a special case, if A and B are independent events, in that case, probability of B given that A is going to be equal to probability of B. That makes sense. It doesn't since A and B are independent, so it doesn't matter what A is. In this case, probability of B given that A is going to be equal to probability of B. In this case, I just this becomes right here. This becomes equal to PB. So I'm just substituting this in there, and this probability of A intersection B comes out to be this right here. Okay, we can use the above equation to define the independence of two events. So I can say two events A and B are independent if and only if probability of A and B is equal to probability of A times probability of B. Let's understand this through some examples. Box contains 5 balls, 3 red and 2 blue. This one right here. Two balls are drawn one after another without replacement. What is the probability that both balls are red? So your first draw is red and your second draw is also red. You have to find this probability that both the balls are red. So let A be the event that the first ball is red, and let B be the event that the second ball is red. So A intersection B, in this case, it means that the first draw is a red ball and second draw is a red ball. In this question, we have to find probability of A and B. So we would be using this formula right here. In order to use this formula, you need to know your PA and you need to know probability of B given that A. So let's focus on A first, that the first draw is a red ball, which is right here. Well, what is the probability? The answer is 3 over 5 because there are 3 red balls and there are 5 balls in total. So it's going to be 3 over 5. What is this B given A? It means second draw gives a red ball given that your first draw was red. That's what this B given that A means. So if the first ball was red, then only 2 red and only 2 blue balls they remain. So the probability that your second draw is a red ball, given that the first draw was a red, is 2 over 4 because you only have 2 red balls, right? 2 red balls left after the first draw, and then you have total 4. So 2 over 4, and the answer is 1 over 2. Now, so I know my P given A, and I know my PA right here. Okay, now you can just substitute into your formulas. So the probability of A and B is given by this expression. Putting in your numbers, the answer is 3 out of 10. Suppose you roll two fair dice, this one right here. What is the probability that the first die shows 3 and the second die shows an even number? This one, 3, and this one, an even number. So let A be the event that the first die shows a 3. 3 right there. B be the event that the second die shows an even number. So this would be like 2, this can be 4, this can be 6. A intersection B, it means that the first die shows 3 and the second die shows an even number. Here we have to find probability of A intersection B, or in other words, probability of A and B. So we'll be using this expression right here, this formula. So let's find probability of A first. That the first die shows 3. Well, the answer is 1 over 6 because there is only 1 3 over there. This right here, B given that A, it means the second die shows an even number. So this is my B. Given that, okay, this is my vertical line right here. First die shows 3. So this is my A right here. So because the two dice are independent, what happens in the first die has no bearing on the second die. So in this case, probability of B given that A is same as probability of B. And probability of B is that the second die shows an even number. That would be 3 over 6 because there are only 3 even numbers. So this will be 1 over 2. Okay, I know this and I know this. Substitute in the formula for A and B, probability of A and B. Put this in the equation and your answer will come out to be 1 over 12. You can also verify this from the figure. The question was that the first dash shows 3 and that the second dash shows an even number. Well, the only possibilities are these ones right here. 1, 2, and 3. That's it. These are the only two possibilities where which is A intersection B. So in this case, my size of my A intersection B is 3 and my total size is 36 because there are 36 outcomes total. And the answer is 1 over 12. So this matches with 1 over 12 over here. So you can find the same answer in multiple ways. You roll a die. Let's define two events. A, that the number is even. So you can have 2, 4, or 6. B, that the number is greater than 3. So you can have 4, 5, or 6. Question is this, are these two events independent? Now, they appear to look dependent because both involve overlapping condition on the same die outcomes. Evenness, you can see that there's a 4 over here, there's a 4 over there, there's a 6 over here, there's a 6 over there. So it kind of seems like that they are dependent. And also the size. Look at this. This size is 3 and this also has 3. So let's check mathematically if they are independent. Well, what is the definition of independence? Two events A and B are independent if and only if probability of A and B is given by probability of A times probability of B. So let's compute these probabilities. My probability of A is that my number is even, right? And how many numbers even we got? 50% of them is even. So it's 1 over 2. Probability of B is that the number greater than 3. How many are there? There are 3 of them total. So it's going to be 3 over 6. It's going to be 1 over 2. So I know my PB now. What about probability of A and B? That the number is even and the number is greater than 3. In that case, the only common element is 4 and 6. These are the only common elements between A and B. Let me just remove everything so you can see that. 4 and 6 over here, 4 and 6, these are the common elements. So probability of A and B would be the size of this, which is 2, divided by the total number of elements, which is 6 in this case. So the answer is 1 over 3. Well, let's check our condition now. If A and B were independent, we would have probability of A and B is given by probability of A times probability of B. This we know is 1 over 3. We just calculate that over there. This one is 1 over 2 and this one is 1 over 2. Well, clearly this side is not equal to this side. In that case, I can say that A and B are not independent. You roll a pair of dice. What is the probability that the sum of two dice is greater than 8 and the first die shows a 5? Let A be the event that the first die shows a 5. Let B be the event that the sum of the two dice is greater than 8. So A intersection B, in this case, it means that the first die shows a 5 and the sum of the two dice is greater than 8. Here we have to find probability of A intersection B or A and B. So I'll be using this formula right here. So let's focus on A first. That the first die shows 5. In how many ways can you have the first die showing 5? Only one way. So it's going to be 1 over 6. 6 is the total size of your sample space. Okay, now let's focus on B given that A. In other words, the sum of the two dice is greater than 8. So this is my B. Given that, this would be my vertical sign right here. The first die shows a 5, A. The possible outcomes of B, given that A are these numbers. Well, that makes sense because if your first number, if your first dash shows 5, then what are these numbers so that your answer should be greater than 8? Well, these numbers, they can be 4, they can be 5, or this can be 6. So there are three outcomes over here. So that's why you get 4, 5, 6. So the probability of B, given that A is 3 over 6, 3, because this is the size of 3. If you look at this thing, the size is 3 over here. And the total number of outcomes is 6. So 3 divided by 6 is 1 over 2. Substitute this in your formula right here, and your answer will be 1 over 12. Now let's verify this. We can also verify this directly by looking at this right here. So let me remove everything. So my A intersection B. What is it? Well, my A is 5, right? I mean, the first die shows 5, and the sum of two dice is greater than 8. So in that case, the only possible outcomes are this one, 5, 4, 5, 5, and 5, 6. Only these three ones. All right. So in this case, my size of my sample space A intersection B is 3. And what is the size of my whole sample space? In this case, is 36. So 3 divided by 36, answer is 1 over 12, which is same as this. Suppose an AI spam filter, it classifies email. Based on the past data, we know that 30% of all emails, they contain the word discount in it. 80% of the emails that contains the word discount in it, they are actually spam. How many emails are both spam and contain the word discount? Let A be the email that contains the word discount, and let B be the event that the email is spam. So A intersection B, in this case, it means that the emails contain the word discount and are spam. So here we have to find probability of A and B. This would give me the percentage. In order to find this, I'm going to use this expression right here. So let's focus on A. What does A tells me? It says that 30% of all emails contain the word discount in it. In other words, probability of A is 0.3. This one, it means B given that A. In other words, 80% of emails are spam. So this is my B right here. Given that, so this is my vertical line right here, they contain the word discount in it. This is my A right here. So the probability of B, given that A is 0.8, 80%. That's given to you too right here. Now we can substitute our values into the formulas probability of A and B. Substituting your values, you will get the answer as 0.24. So 24% of all emails are both spam and contain the word discount in it. Suppose 1% of people have the disease. In other words, probability of D is equal to 0.01. There's a test and it is 99% sensitive. In other words, the probability of getting test as positive given that the person has a disease is 0.99. And also given to you is the test is 95% specific. In other words, probability that the test is negative given that the person does not have the disease is 0.95. What is the probability that a person has the disease and the test is positive? In this case, you have to determine the probability of disease and test is positive. So in this case, D and T plus. So we would be using this expression right here. All right. So using that expression, this will be equal to probability of disease times probability of test positive given that he has a disease. Substitute your numbers and you'll get your answer as 0.0099. Sometime in the question, they give you additional information just to throw you off, just to see if your concepts are clear. This information is not needed over here. The only information you need is these ones. This one is useless information for this question.